We're back for our second segment. I'm here with Tom Coughlin, Steve Ohr, and Bill Weir, who are going to talk to us about trends in 2017. And when we finished up our first segment, Steve, you were posing a very interesting question. So why don't you tell us again what was on your mind?
Well, actually, we make several questions out of it, and I suspect that we'd come at it from different angles. Mm-hmm. But I'm curious, with the environment dominated by financial people, what is the new engineer? Is the new engineer someone who keeps his head down, afraid that somebody's going to swing a scythe and he'll lose something? Or is this a new, bold technician to advocate high technology, PCI Express, the rapid data transfer, or is in fact the role totally different? Does he become an advisor to an Apple or a Amazon or to a Google? Do people regard the new engineer as a guru capable of creating magic, or is it is the engineer third levels down told to worry about his sub-nanometer CMOS and otherwise leave the plant alone?
Actually, Steve, what you just said is pretty close. That last case. Technical talent. There's a strong technical ladder in most companies that I've seen, and their job is to deliver the technology. Now, who tells them what the technology is the other side of it. And typically there's a technical business development person who is a little more strategic, who works in parallel with the technical ladder. So if you want to call it, sometimes marketing, technical marketing has that role, sometimes business development. In some companies I've been in, HP was an example where the lab, as they called the lab heads, were actually very astute in terms of market and what technologies they needed to do. So the same guy that was managing maybe 30 engineers also was able to have enough time to spend looking at future trends, what do we need to develop, which kind of goes into the buy or build thing. Can my group actually do what the business side is saying? If we can't, we may have to acquire another group of engineers. If we can, then okay, Mr. Technical Ladder Leader, take my 30 engineers and go do that. So I'm hoping I answer the question. I think there's a nice exchange between the technical ladder and the strategic business side. I think you need both working together. And frankly, most peers in companies that I've been in were very sharp in areas that my expertise was in, and I had to be very sharp technically in order to communicate with them. So I think at that level, if you're in the business long enough, you can kind of cross business with the technology side.
Well, especially in this area where we're at, where we live here, a lot of even the people that are the business people are technologists.
Yes.
A lot of them are engineers. Yeah. We are a place that's built on engineering. The knowledge of how things work, the ability to see things in a systematic way, and I think that it pervades the whole culture, whether you're the business side of it or the guy working in the bench. All these people tend to have knowledge or at least appreciation of engineering and of technology.
I agree.
Yeah.
I think, in fact, I could make the argument that if you look around the valley, folks like maybe yourself or Steve or myself, that you may say maybe your business card now has some business or marketing or something in it. We all started as engineers, and you really don't lose that. You still need to maintain that to be relevant and be able to have conversations with very technical people.
What we have is we have the orientation, we've got the sort of trained mindset. The thing that's going to change all the time, especially nowadays, is exactly what are the details, what are the new technologies. It's about every 5 years, I think, you have to be thinking about how do I retrain myself, how do I stay relevant? Because things are changing so quickly. So I think an important part of being an engineer today is whatever it is you're working on, you need to stay current. You need to be on top of what are the big trends, what are the things going to move the industry.
Yep.
So being the best engineer in the 286 architecture will no longer help you?
Probably limited. there's few applications of it. Well, you know, the interesting thing is now you may end up doing embedded stuff.
Yeah. Or it's a footnote on your resume, and now you're working on the next generation Xeon platform.
Yeah,
right?
that's more typical.
Because it's just another building block in your long technical ladder career, right? And you look for guys like that, right?
Because you need them.
Absolutely.
Yeah. It's an ecosystem. It really is, you know.
Yeah.
And so, in that line, some companies have the ability, financial ability, to have a skunk works, where they can have engineers who have greater freedom to look at new problems, look at old applications for new problems, new applications for old problems. Do you think that is something that should be encouraged across the board, or is it something that companies facing fiscal constraints just simply can't afford?
To answer the question, I think there's less skunk works, unfortunately, because it is constrained or driven by financial goals, and they're going to say, why are you spending $10 million to fund this small group of guys? On the other hand, if you think back, some of us remember Bell Labs. I could argue that half of those giant towers out there in Homedale were Bell Labs. Well, I used to call on them back in the day, were probably arguably skunk works, that people that invented radar or the transistor or X-rays or whatever it may, or the first, you know, I think I mentioned the first transistor. A lot of these things came out of groups that didn't have a specific goal that were tied to some business plan that was going to increase the stock price. It was just, hey, let's go out and see over in this area what we can do. Let's move some electrons around and see what happens with it. I wish there were more of that.
There is some of it though, like there's a lot of the Google Labs projects, things of that
Yes.
sort. And there's still this thing, there's some people have it like, you know, 10 or 20% of your time you do a project that's your own. You know, there's still a certain you know, in some companies I think there's some of that. And that really I think helps to get some of those off-kilter stuff. You try something out, you know, you see if it works. If it doesn't work, you move on and do something else. Well, you need that. I don't think we'll have innovation without some of that going on.
And unfortunately, at least on the IC side, I don't see as much of it on the IC side. Most of the companies that I'm familiar with pretty much are lean and mean. If anything, they're missing people here and there, or somebody leaves, somebody told them somewhere, we can save X amount of money if make these other two guys fill in the hole, rather than the other way around. I think, I personally don't think I've ever worked in a company, possibly HP, maybe one exception, that ever came to us and said, you know, we have an extra 10 or 20 million bucks, why don't we go fund something? And I've never heard anybody really say that, at least in my history. So.
And maybe that's part of the, you know, the investment guy, the finance guys getting into it, like you're saying.
Platform guys may have more money, like a Google or an Apple, to do that, and I'm sure they do. Inside those companies, probably have some skunk works going on.
I think Steve wants it.
Well, we're thinking about 2017 and beyond.
Yeah.
And we've identified the changing engineering environment.
Yep.
I'm wondering if we look at some of the dramatic markets, the Internet of Things, the connected car, the smart home, the revolution in healthcare services, whether you need a different engineer for each of those environments, or do you cultivate a versatility for the engineers who are under you? We can do IoT, we can do connected car. Our talent base
That's difficult.
That's difficult, okay.
That is difficult. I think you put together teams that are really good at building CPUs, and CPUs are very specific these days, right? Now you could say I'm a micro-architect and I can architect a CPU. It could be aimed at IoT, it could be aimed at storage, it could be optimized for a notebook or something like that, right? But more and more people are quite specialized out there, at least that I've seen. If I go visit a group, that group is pretty much focused on server and storage. Another group may be focused on networking. There's so many details, so many specs, so many technical things to keep up with. I think it's become more difficult now for one person to try to say I'm a jack of all trades. It's pretty tough now.
Well,
is do
as
that.
we create these vertical silos, how do you create the horizontal connectivity so you have cross-pollination between these disciplines?
That's what consultants are for.
That's a nice
Good
pitch,
answer.
But, apart from that,
No, but I mean, in a sense it is. It's almost like sometimes in order to be able to span between disciplines, you need somebody from outside, at least outside the disciplines.
Actually, my company just went through that. We hired a consultant to learn how to design semiconductors and other processes, because our skill set, for example, might have been in CMOS, which is very common, but it doesn't mean that you're good at designing in bipolar or bi-CMOS.
Right, right.
So I think it's very legit to hire in, and again, this is almost the internal, do I build it or do I buy it? You're actually renting out people, sort of buying them for some short period of time to teach you these new skills.
In a sense, you know, we look at the cloud, and the cloud is like everything as a service. You sort of use things as you need it. But in a sense, we all are sort of becoming that way. Or there's a lot of people out there that are sort of you as a service. You come in, you do something, and then you go off and do something else. So in a sense, you have to, you mentioned the scythe before, you have to embrace the scythe, because we always live with the scythe.
So the cross-pollination, I think, that's one good way. And another way is to reassign engineers between groups. And I've seen some of that, maybe not as much anymore, because I think it is getting very difficult for a given engineer to be an expert in so many different silos, technical silos.
The other thing is where someone outsider comes in is you get mindsets, you know, within groups in a company. And sometimes it takes somebody from outside to come in and like give another perspective or try to span between the two.
yeah, the not invented here.
Or not invented there anywhere.
Prejudice.
Yeah.
Yeah.
Well, so if I'm a young engineer, and I suppose at one point in my career I was, and I wanted to both maximize my potential earning potential as well as to increase my own skill set, what would any of you suggest that I do to avoid being pigeonholed into a very narrow discipline?
You know, it's not bad to learn a narrow discipline to get the skills. And most people do start out with that. I mean, to start out with being some type of an engineer working on some particular thing, because it forces you to understand something from a very basic level. And it's not a bad place to start from. But then as you go through things, you'll end up doing more things that are slightly different from what you do. You pick up experience, you pick up new opportunities, new people you know, because again, it's really about the people too.
Okay, and looking forward into 2017, is there any particular area that you would suggest to someone who's recently entered the workforce, whether it's, you know, the cloud or IoT or any other area?
Software.
Virtual reality, other one?
Yeah.
Okay, so why do you say software?
I think this is a throwback to many of us started decades ago as hardware engineers because there really wasn't much software. And now you see companies coming out, people getting rich in software oriented or service oriented, like a Facebook. You know, you put together a bunch of code, you start a website, and you're immediately rich and go to Tahiti, right? It's much more difficult for the hardware guy to copy that model anymore.
They're
you
just
know,
delivery.
yeah, we're just delivery or
mechanisms.
just you know, just the basic building blocks. It's all the code that runs on it now, right? So those are the superstars now, and I think a lot to a great extent. They're the ones that generate all the lines of security code. Now, arguably, you have to have the hardware platform that can run that and execute on that, but more and more I see where software has become, you know, I think the king in terms of innovation. So much is being done at that level now.
Yeah.
You know, even I just recently bought a new cell phone, right? And in order to make it work better, it gets downloads every now and then. So somebody's writing lines of code that said, oh, when we initially launched this product, it was 80% efficient, but we met the market window, going back to that, right? So through software now, you can upgrade even cars. You know, my car got taken in and they changed how the engine works and now it's more efficient, all through software upgrade, right?
Let me raise a subject near and dear to your heart probably, analog skill sets. My feeling is that's a good place to be but that's changed. That it used to be you would go into a Maxim or a linear technology and find an engineer with an entire product line that he created, that he supports with test vectors and manufacturing tips and die shrinks over the years, to a team looking at something like call it a PMIC, complicated part that does the juggling act for the voltages in a cell phone, which depends on much more of a team effort. Depends on a lot of simulation, a lot of cranking through data. Between those two extremes, is one engineer called across the counter to help with the other, or is this segmented still segmented?
Well, so let me answer it this way. I think the role of an analog engineer, for example, has changed over the years as protocols have gotten extremely fast. You know, earlier we were talking about a good example is PCI Express.
Yes.
It came out maybe 11 years ago from Intel, right? Because it is the language of the processor.
As a computer bus, yeah.
Right.
Yeah.
So it starts off, you know, at 2.5 gigs. The clock rate's half of that, and now the next generation is going to be 16 gigabits. Now, there's a lot of issues to designing platforms and designing ICs and all the components in between to make them work with a clock rate of 8 gigahertz, right? You look at Ethernet, where they actually have serial pipes at 25 gigabits, and they have their eye on 100.
Yes. In the data centers, there actually are some 100.
These are now almost waveguide analog type issues to solve at the board level. The company I'm with happens to make a whole product line dedicated to improving signal integrity. And the signal integrity managers and engineers that I interface with at in our customer base, which are all the tier 1 customers out there, right? These are all old analog guys that understand the board level issues, the parasitics, the inductance, all this kind of stuff. And you really do have to have a good grounding in analog background to understand these high-speed signals, how to solve the issues that they cause in your box, how to route them, how to make them work, how to get the signal from one end to the other. It's very difficult.
I'll give you another 2017 thing to look at, and that is materials printing. So beyond just traditional 3D printing, that printing multiple materials, which may include electronic materials also. There's some very interesting things going on in there. And I think will be big enablers for a lot of mobile technologies.
And so what is going to be the industry that's going to benefit the most from that?
I think all these small consumer devices are potentially.
There is I believe there's a printed electronics conference going on Santa Clara next week. And for looking at the printed electronics, answer to your question, we're seeing it is in electronic labeling.
Yes, that too.
Not just RFID tags, but in fact labeling that would do a function such as tell you whether the package has been abused, or I've seen this with frozen food, where
how fresh is it?
How fresh is it? If it has someone exceeded the temperature and then refroze it, which could present a health hazard. But not only does that give the grocer an idea how fresh this product is, but by being able to tell the temperature rather than guessing at it, actually saves the trucking industry quite a bit of revenue.
Yeah, that makes sense.
Those are pretty big applications.
Right.
You know? And that sort of thing, eventually you could read your refrigerator could tell how old your milk was. You know.
Exactly. But then there's in the medical area, there are people who are working on skin sensors.
And they're printing skin now.
Yes. This company MC10. That has and I think it's similar to a company called Electrozyme. What they're doing is examining the skin for sweat, but they're also looking for alkalines.
Oh yeah.
Some of the Electrozyme had done work on military contract to the Army, trying to soldiers in the battlefield of Iraq, carrying all this heavy weight and under desert heat conditions. How depleted are they? They can't say, "I'm thirsty," and that's
how stressed they are.
Right.
Yeah.
But the more commercial implementations are for athletes. Do they need to hydrate? You can actually look at skin. So, but this would be an application for printed sensors.
Right.
So that's what I mean. We're getting starting to get a command of being able to like print things depending upon their use much different than they've ever been able to do with conventional manufacturing.
Yeah.
And I think that has humongous potential.
I think they have a 3D printer up on the space station, if I recall. Yeah.
Yeah, and
Make
they're
tools
using for fixing parts in the field, you know, for field repairs of things.
Yeah.
So you're now talking to the younger me who's looking to go into that field. What type of specialty would I want to focus on? Would it be in writing the software for those devices? Would it be architecting the devices themselves?
There's opportunities in all those, I think, you know, basically.
And what I'm noticing is a spread that a company like InvenSense, count on them for motion sensors.
Right.
Well, guess again, they're doing microphones, they're doing other types of sensors. Before our meeting today, I had an opportunity to look at the website for T&E connectivity. Recognize the old Tyco.
Tyco.
Oh yeah.
Very heavily invested in medical sensors, pressure sensors, blood pressure.
I visited Fujifilm actually earlier this week, and they have a whole bunch of sensor stuff they're doing, for instance. It's a fascinating area, and I just, you know, in terms of trends for next year to look at, that's one. Another one I think is the impact of virtual reality and augmented reality.
Well, sensors, you know, thin film technology in semiconductor processing is how they print cameras, and that's what they use, you know, basically a capacitor. That's been around a long time, and what you're talking about, you know, speaking of trends from 2017 on up, people are just building on that.
Yeah.
You know, they look at that and go, okay, there's a foundation, but look at the basic process. We can apply that to other thin film technologies.
Did you see that new camera that looks a little bit like a phone, but it's got all these lenses on it?
Yes, I have seen a picture of it. I'm not sure.
So it takes all these different pictures, different types of pictures at once, and it makes a composite from all of those to give you the best image possible. You know, so it's going to be able to something you can carry with you like that to compete against a DLSR. You know?
Okay. Huh.
It's pretty cool.
So if you were going to pick winners and losers for next year, why don't we start off with the winners? We'll start with you, and then we'll go down the panel. A winner for next year.
In my wheelhouse, I think storage and data center is a winning area. The other area I would say is the area of automotive. You know, connected cars is really big.
Okay. Steve?
The thing that's preoccupied me for a while is the Internet of Things, because there's so many technologies, so much intelligence that's being pulled along with the spread of sensors. You have a degree of monitoring and control that you may not have had in previous generation. We're moving toward this. Somebody would ask, okay, what do you do with a 16-bit A to D converter with a successive approximation architecture? You have to be a specialist to answer that, because the successive approximation is going to be slower than, say, for example, a radar processor. With the Internet of Things, it feels like there's something everyone. You've got the control element, intelligence, memory. You've got your sensor element. It could be moisture sensor, could be temperature sensor. It could give
RF.
Right. It could give you readings every 50 milliseconds, or it could give you readings every 2 minutes. But you have a market for that. My particular feeling, the processors. We opened up, Junko opened up the lid of that access point that NXP took to Germany. You see all the old, not old, but free-scale processors in there. Right. So the Kinetis, the IMX, the parts that were initially branded Freescale before they were acquired, those parts are being put to use. Part of the inspiration, all the baby monitors saying admin, admin, it was you could go to a distributor an AFNet, a Pioneer, a Mauser, a DigiKey, you can equip an entire home laboratory with the parts that they'll sell you. If you're inventive and clever enough, maybe you can build the next generation secure baby monitor.
The tools to invent are just,
Right.
so much stuff out there now.
So it's not so much a question of whether it can be done, but whether it should be
Right.
done.
Or whether they'll you create your talking room, and does Google want to buy you for $3.2 billion? Well, maybe not this year, but
There's that
There-
too,
there's
right?
that.
Then there's that, yeah.
Well, turning to virtual reality and augmented reality that you were talking about.
That's one of the things. So there's three things. That's one of the things I'm interested in is virtual reality. One thing I think we might look for this next year is perhaps the first ventures into long-form virtual reality. Most of this stuff has been very short-form stuff.
Well, why don't you distinguish for the audience the difference between short form and long form?
Short form, for instance, would be a virtual reality music video. For instance, there's a YouTube music video, a song for somebody, for someone, that's done in virtual reality, and they move from one person playing it to another person playing it. And that's, just a music video to something that could actually be more like a story. It could be a traditional type of, maybe a short movie or a short story of some sort that actually tries to bring in additional artistic elements and the normal things we see in scripts and things like that. So something that's a lot more, it's built as a virtual reality type of entertainment. I think that's something to be looking for, because I think there's people working on that. Also, in the storage area that I work in, I think a key thing that's happening, it's going to be happening, and next year I think it's going to be one of the landmarks of doing that, is the replacement of volatile memory with non-volatile memory. The volatile memory that is the high-speed memory, often called DRAM or SRAM, and the caches inside of all the processors we've got are built with technologies that you have to refresh it, you have to put electricity into it every once in a while in order to retain the data. With a non-volatile technology, you do not have to do that. And there are emerging solid-state memory technologies in combination, for instance, with flash memory solid-state drives that I think are starting to move in to provide alternatives to that volatile memory that would allow you to, for instance, have enormous power saving in devices. I can turn a device off and I'm not using it, it comes back up and maintains its state. I'm instantly on. I think that's an important one that's going on too. Plus the general movement and increase in terms of higher performance storage capability that's going to be available to us, as well as the continuation of traditional storage devices like hard drives and even magnetic tape.
Is that something that you would describe as a disruptive technology that will take the place of volatile memory?
What I see it as, so there are whole new computer architectures. It will be disruptive. There will be whole new computer architectures that are built around the idea of, first of all, a non-volatile memory cache. The other thing is, there's a whole bunch of stuff going around of bringing the memory and the compute closer together. There's major initiatives going on. They're all part of this, having these higher speed, vaster type of memory devices that are out there, non-volatile versus volatile. And there's new interfaces like on the PCIe bus.
Right.
There's something called NVM, non-volatile memory E, which is a interface built on that for storage. And I think next year is going to be the year we're going to see major advances in products in that, both as direct connection, but also as what's called a fabric, where it's actually a networked connection with switches and ways in which you can move data around, for instance, within big racks and data centers, within the boxes and within racks and data centers.
Yeah, if you think about the data center, if we could just dwell on that for just a minute, I mention it, Tom mentions it, we both view it from a little bit different angle. I'm a little more inside the box, where the speeds and feeds are increasing so greatly to handle all this data, as we talked about. And my company is developing products to be able to handle that in this new environment that he's talking about. Clearly, the folks that are building hard drives today have started to hit a wall. You can only layer so many platters and have so much density on a phonograph record, so to speak, right? And if you try to put more on there, and they can, but the latency to access it becomes longer. So there's kind of a point of diminishing returns, where now to get that much fast access, you almost have to go to non-volatile, NVMe arrays and flash and this kind of thing. And people have been at this for a decade now. but the price point has always been tough. It's only been the most critical, fastest access need that could afford what they call, typically a basically a hot scenario, where hot meaning you have to access it very, very quickly. For example, maybe the stock market has servers with a lot of non-volatile memory because the transactions have to happen so quickly. What doesn't is maybe you want to look up a picture of your grandmother on Facebook, okay? You don't care if it takes you an extra half a second, right? That's kind of warm and cold storage level stuff. But eventually that's all going to be converted. Now, hard drives might be okay for that, but over time, next 5-6 years, the prediction is starting 2017 on to maybe 2022, you're going to see this big rollover in data centers and the way we store things.
Can I just have a picture of Nana in my wallet?
You can do that too.
Okay.
That's actually back to the analog idea, right?
We have about 30
you have an
seconds.
analog picture.
30 seconds left, so let's pick up Steve's point.
I'm going to coattail on Bill. When you think of the data centers, please, please, please remember power management.
Absolutely. I know that's your area of expertise and has been for a long time. I'm not in that particular area, but I can tell you all the products we make, without exception, every customer talks about the need to reduce power and manage it. And although I'm not personally involved in those kinds of products, I see that every single time we're having a conversation. The products that I handle, they'll always go to the power dissipation number. Are you looking better than anybody else out there? What can you do to get it down another 10 or 20%? Here's my budget. How do you meet that? So to your point, that is a critical function.
It is.
Yeah.
Power costs money.
Yeah.
It goes up in heat.
Yep.
So you think of a giant data center like a Google or a Facebook has. Imagine the BTUs it takes to get rid of all that. Boy, wouldn't they love to have better power management, lower power products, and so forth.
I mean, that would bring us into a whole nother discussion, including battery technology and the like. Unfortunately, we're running out of time. I do want to thank my panel of experts. We have Tom Coughlin, Stephan Ohr, and Bill Weir. Interesting discussion. We could go on much longer, but we're out of time. So thank you so much for joining us. This has been Global Innovation, and I have been your host, Chris Graham. Thank you.